Welcome. Today we are looking at functions, and in particular we're looking at the quadratic and the linear function. Now, I'm sure you remember this, but just in case, remember a linear function is a straight line graph, and a quadratic function is the parabola. Now, the parabola is the real important one, in that sometimes they mix the parabola up with other kinds of graphs, as you'll see as we go. But we're starting first of all with a question involving those two graphs. Let's just quickly recap a little bit. Okay, if we look over here, remember I've said to you this is what we call the straight line. And that has the form of y equals mx plus c, where c is the y-intercept and the m is the gradient. There are other forms of it, but this is what we call the standard form. And then we have the quadratic, which is better known, I'm sure, as the parabola. And that has the form of y equals ax squared plus bx plus c, or y equals a x minus p all squared plus q. This form is the general form, and this is the standard form like this one. This one tells us something. The a tells us about the shape. Now you'll see later on we will deal with a question around that, and I'll go back and recount it. The x equal to p gives us the axis of symmetry. And the q gives me the y value of the turning point. So, in the light of that, let's go to the first question and see what it's actually asking us. Right, it's adapted from February-March 2011, paper 1, question 6. And the question says, a parabola f intersects the x-axis at B and C. So we can see there's B and there's C. And yes, that is where the parabola is cutting the x-axis, and the y-axis at E. What they don't mention to us, and this is what's important, is in actual fact there are 2 points shared between the parabola and the straight line. So let's change our color pen, and I'll highlight those. If we look over here, the E belongs to the parabola and the straight line, and the C belongs to the parabola and the straight line. So in actual fact, we have facts to do with both graphs using one of the equations. Well, why is that good news? Because the only thing they tell me about the parabola other than that is that the equation of the axis of symmetry is x equals 3. You can see they've written it in there, so we don't have to worry about that. Now, the line through C and E, which is our straight line, has the equation y equals x over 2 minus 7 over 2. Now, does that take the form of y equals mx plus c? Yes, it does. So in actual fact, we already know what our y-intercept will be, because our y-intercept is our c value. However, I'm going to act like we didn't know that, and we're going to work from very straightforward basic principles from the beginning. Right, so let's see what the question starts with. The question says, show that the coordinates of C are 7, 0. So the coordinates of C, I want to show that it's 7, 0. Now, how do we find an x-intercept? Well, hopefully you're all screaming, oh, it's easy, we let y equal 0. And that is truthfully what you do. So if you want the x-intercept, you let y equal 0, because at that point the y-axis is 0. And if you want a y-intercept, you're going to let x equal 0, because that's where you want to actually get your value for y when x is 0. So what I want you to remember, that over here, this would be where x is 0, and this is where y is 0. So right, let's get another color pen just so we don't mix up the different bits of work. Right, so let's have a look how we're going to do that. We do have the equation. Let me just take the page up a bit. It's y equals x over 2 minus 7 over 2. And we want the x-intercept. So what we have to do now is we have to let y equal 0. Now, if y is 0, 0 is equal to x over 2 minus 7 over 2. Now, the good news is that all we have to do now is multiply through by 2. So we would times this by 2, this by 2, and that by 2, and we would get 0 is equal to, those 2's would divide into each other, and those 2's would divide into each other. And so we would get that. And so, yes, x is equal to 7. So the coordinate of C is 7, 0. Have we shown them what they asked? Yes, we did. We've given them the answer in a coordinate form. Now, this is just for the sake of examinations. If for whatever reason you could not do this question, but you could do the next one and the next one, whatever you do, don't stop working. So what I'm telling you to do now is, if they've said to you, show that C is the coordinate 7, 0, then all you would do, if you couldn't do it, you'd say, assuming C 7, 0, and you'd keep going. Right, so let's see what they're going to ask us next. Right, so we've now established that this is the coordinate 7, 0. Right, it says calculate the x coordinate of B. Interesting question. Remember, we know that this is x equal to 3, and we know that this C value is 7, 0. So what do we know about an axis of symmetry? Well, an axis of symmetry on your face would be a line straight down your face here, and assuming all things being even, you should have an ear on either side, an eye on either side, etc. So the same with a parabola, if it's an axis of symmetry. If we have an x-intercept this side, it must be the same distance that side of the axis of symmetry. So let's go and have a look at it. If I look here, from this point to this point would be 4 units. So because this is an axis of symmetry, I know from here to here must also be 4 units. And so could we have any problem finding B? No. All we're going to do is we're going to take 3 and subtract 4, and we're going to get -1, 0. So how am I going to show the examiner how I did this? It said calculate the coordinates of B. So what we would do is we would say B is -1, 0, and I would write here from symmetry. So the examiner knows what I've done. It's not essential, but you know what? It's always a good idea to make your examiner, or the marker at least, happy. If they see nice instructions given to them on the paper, it's easier for them to find out what you were doing in case you make a mistake, which means they can give you method marks. So in this case, all I would do is pop next to it, from symmetry. Okay, so let's see what the next part of the question asks. So right, here we are. We're still looking at the same question. We have established that that's -1, 0. We've established that that is 7, 0. And this question now says to me, find the equation of f. F is the parabola. You can see there's the f there. So that's what I'm looking for, the parabola. So if we're going to find the equation of a parabola, there are 3 possibilities. The first possibility is that we know the x-intercepts and one other point. Well, I think we're nearly there because we've got both the x-intercepts, and we would need another point. And if we look over here, remember we've got E, and E is the y-intercept of the straight line. So we also have the value of E. So that looks like the winner, but I'm just going to mention the other 2 just in case. The second one is if we know the turning point and one other point. In this case, we don't know the turning point. We do know another point, but we don't know the turning point. All we know about it is that it will be 3 something, but who knows what the something is at this stage? We don't know. And the third one is the way we are given any 3 points. Now, you've got 2, and yes, you can find this one, but any 3 points is usually done by simultaneous equations, and it's quite hectic. So if you have a choice, like you've got your 2 x-intercepts, it's much better to go with that method. So let's just remind you about it. Right, the method goes as follows. It says y is equal to a, x minus x1, x minus x2, where these are your x-intercepts. Now we know the 2 x-intercepts. Okay, we know that the one is -1, 0, and the other one is 7, 0. So if you like, we could say x1 is -1 and x2 is 7. So we have y equals a, x minus -1 and x minus 7. Notice that that minus stays there, and the minus from here comes in. So an actual fractal bracket is going to read a, x plus 1, x minus 7. Right, so that's really nice to know. But we still have a problem. We don't know what this is. So that is why we need the other point. So we're going back, and remember we've said the good news is we know this equation is y equals x over 2 minus 7 over 2. Let me just make sure I haven't written that down incorrectly. Now I have written it right. And I know that this is actually the y-intercept. Now if we know the form y equals mx plus c, we know that this coordinate must be 0 minus 7 over 2. But I'm going to show you how to do this properly as if we didn't know the form y equals mx plus c, just in case you get a different format on the straight line graph. Right, so let's have a look and let's choose another color so that we can work it out. So now what we need is the y-intercept of y equals x over 2 minus 7 over 2. So for an x-intercept, we let x equal 0. So if x is 0, y is equal to 0 over 2 minus 7 over 2. Well, what do we know about anything over 0? Or rather, let's rephrase it, 0 over anything. The answer is 0. And of course, that means your y is minus 7 over 2. So you have coordinate 0 minus 7 over 2, which is precisely what we said it was when we used the fact that that was in y equals mx plus c form. So really, if you know that format and you recognize it, it just saves you some time, but it's not impossible to do it just from the very first principles of how to find a y-intercept. So there we have it. Now we have another x and y value that will satisfy that equation. So right, let's get another color. I love these colors. It livens the whole thing up. So let's have a look at it. It's going to be y equals a, x plus 1, x minus 7, and we are going to use this coordinate. So we're going to say minus 7 over 2 equals a. Where there's an x, we're going to replace with a 0. And we're now going to solve. So minus 7 over 2 equals a. This is going to be 1 times minus 7. So minus 7 over 2 is equal to minus 7a. Now that means that a is equal to minus 7 over 2 divided by minus 7. Now remember, if you've got a whole number, the best thing to do is to make it a fraction, because then you've got a fraction divided by a fraction, and it's easy to work with. So all you're going to do is you're going to take the bottom and you're dividing. So the rule is tip and times, or invert and multiply. So my a is equal to minus 7 over 2 times minus 1 over 7. The 7s divide into each other. A negative times a negative is a positive, and we're going to get that a is a half. So what do we know? We've got the equation y is equal to a half x plus 1 x minus 7. Now yes, that is a parabola, but are we actually finished with this question? And the answer is no. We have found an equation for the parabola, but we haven't actually found what they asked us for. If we go back to what the question asked, it asked you to write the equation in that format. Now there's two ways we can go about this. The one way is to go and times that all out, simplify, complete the square, which is probably what most people will do. Or we say, look, we know a form of it and we know the x value of the turning point. Now remember, the P and the Q is in fact the turning point. Now if we think like that, we can make life really easy for ourselves, because all we're going to do is find the Q value by substituting in x equals 3 and then going and plonking it into the equation. But I'm going to go the route that most people will go, and then we'll go back and we'll try the other way just to show you how easy it would have been. Right, so here we have, let me not take it up too high. Let's times this out. So it's y equals a half. Multiplying this out, we're going to get x squared plus x minus 7x. So it's minus 6x. And that times that is going to be minus 7 over there. So y is equal to a half x squared minus 3x minus 7 over 2. So that's the equation of the parabola, but not in the form they asked for. So we're still not finished. We still have to work the form. So just to refresh you on completing the square, I'm going to do it with you now, and you can see how it works. Right, so if we're completing the square, let's change pens again so that it's clear I'm starting a new bit of work. this is quite a demanding question in this fashion, the first thing we would do is we would take out the half as a common factor. So it would give me x squared minus 6x. We'd leave a space, but remember we'd only take it out of those two, and we'd leave the minus 7 over 2 outside the bracket. There are several ways of completing the square. This is the most traditional one. So I'm doing the most traditional. If you've been shown another way, that is fine. As long as you end up with the same answer as me, that is perfect. Right, so over here we equal, and now what do? We take the coefficient of minus 6. We times it by a half, giving us minus 3. We square it, we add it, and we subtract it. So we're going to add it as 9. But we have to subtract it as 9. But you've got to watch out for this method, because you must still times it by the half outside the bracket, because the 9 that you've got here and the 9 you've got there, both are affected by that half. So that must be, so you must take off exactly what you added in. You can't do part of. Right, so what have we got? We've got a half, and we know that this is a perfect square, so it's going to be x minus 3 all squared. And over here we've got minus 7 over 2 minus 9 over 2. Now this is quite friendly numbers, fortunately. So we have equal to, sorry, I've jumped off the pen. Let's go back to the pen. Equals a half x minus 3 all squared minus 16 over 2. Because remember, if the denominators are the same, we can add the numerators. Now minus 16 over 2 is a nice number. We can rather write it as minus 8. So quite a performance to get it into the form they want if you take this route. Now let's go back and just check, were there marks given for the question? Yes, it was 6 marks. One can understand that being a lot of work. If it was 6 marks, how would I give the 6 marks? Let's take the pink one and see if I can show you. I think the first thing I would have given a mark for was for having found that point. Then for having substituted in at least another point there. For eventually getting the equation in any form would be a 3rd point, I think. Then I would give you at least 1 for completing the square. And 1 here, so we still got 1 more, so I probably would have given another 1 somewhere here. Probably when you do the substitution of that point. So I would get my 6 marks like that if you did this method. However, the other method is also relatively easy, so let me show you how that would have worked. Right, so if we do the other method, let's just rule off here. We had y is equal to a, no sorry, it was a half already, I had the half, sorry. Let's put it back. A half x plus 1 x minus 7. Now remember I said to you your turning point, we already know the x value is 3. So all we're going to do is find out what the y value is if x is 3. So we're going to substitute, let's just take it up a bit, x equals 3. If we do that, y is equal to a half of 3 plus 1, 3 minus 7. So it's a half of 4 times minus 4. Now, 4 times minus 4 is minus 16, and a half of that is actually minus 8. So we have a turning point of 3, negative 8. So your equation must be y equals a, which was a half. Remember, that's your p and that's your q, and the equation goes y equals a, x minus p all squared plus q. So it would be x minus 3 all squared minus 8. Right, now I think this was a slightly better way of doing it, or easier way of doing it. And I think what it comes down to is how confident you are. If you're not confident, rather stick to the tried and tested ways versus the shortcuts, but this is really neat and elegant. Right, we are going to go to ad break for a little bit, just to give you some time to think about what I've had to say, and when we come back we will continue with this question. See you after the break. Hi, welcome back. Hope you had a good break. We are now going to still continue with question 1, and we're going to look at 2 more subsections of the question that are slightly different and nice and demanding, worth looking at as revision for your examinations. Right, let's look at it. Right, now we do have the equation of the parabola. I just want to write it in here so we can refer back to it. Okay, and we do have these points, just in case we need them. I don't know if we do. Let's see what the question says. The question says, write down the equation of the graph of H. Now, H is not on our drawing. The reflection of F in the x-axis. Now, I love questions to do with reflections, because if you get stuck, you can just think logically. You can say, okay, imagine I've got a little axis over here, and I've got a coordinate, say, 3, 2. And I want to reflect that point about the x-axis. Well, if I'm going to do that, it would be here. So what would have changed? Well, would the x change? No, the x would still be 3. Would the y have changed? Yes, the y would have gone from 2 to minus 2. So we have 3, negative 2. So what has happened? When we reflect in the x-axis, we change the sign of y. Okay, so let's go to the equation we've got. The equation we've got is y equals a half x minus 3 all squared minus 8. And as I've just said to you, by simple deduction, we know we must go minus y equals, and the rest will stay as it was. So we've changed the sign of y, which is all we have to do for reflection in the x-axis. Now, obviously, a negative in front of the y is not a good idea when we're doing graphs. So we're going to take that negative and multiply negative 1 right the way through. So negative 1 times this is going to give me y. Negative 1 times that is minus a half x minus 3 all squared. And negative 1 times negative 8 is positive 8. So what have we done? We have taken our parabola that was a smiling face, and we've turned it around so that the turning point is up here. It's more or less how it looks. Now, is that a reflection? Well, yes, think about the original. The original looked like this. So yes, it makes perfect sense. That is a reflection in the x-axis. Okay, so good. We know that the coordinates of this is 3, 8, whereas the coordinates of the original were 3, negative 8. Has the sign of y changed? Yes, the sign of y has changed. Okay, let's go to the next part of the question. Now it says, write down the maximum value of t of x, another one. So we started with f and g, now we've got h, which we've just found, and t, a completely new thing, t involving negative f of x. So let's think about it. If that's so, t of x must equal 1 minus, and in place of this, we must go a half x minus 3 all squared minus 8. Because that was the equation of f of x. Right, now knowing that, we know that this will become 1 minus a half x minus 3 all squared plus 8, which is minus a half x minus 3 all squared plus 9. Right, so what is the maximum value? Well, the maximum or minimum for a parabola always happens where there is a turning point. Okay, if we think about a cubic graph, which of course is particular to your matric syllabus, we have local maximums and local minimums. So they're not true maximums and true minimums. But a parabola, it's a true maximum or true minimum. If our a value is negative, we know it's a sad graph, so it's going to go like this, which means it has a maximum value. This is a sad graph. It will turn like this. And the turning point of this would be 3, 9. Okay, so the maximum value, the most the y can be, is 9, because that is the y value of the turning point. Okay, so we've got it clear. The other ways we could have thought it through, I'm going to mention it to you for those of you that are feeling more confident. This is safe. You can't really go wrong if you do it like this. So let's just go for a little bit more confident approach. What we could do is we could look at this and we could say, okay, y equals f of x. We had the turning point, 3, negative 8. If we've got y equals minus f of x, we've already decided that's when we reflect about the x-axis. The turning point would be 3, 8. Now, if I've got y equals minus f of x plus 1, well, then all the turning point's going to do is it's going to increase by 1. And so the maximum value is 9. So either way, whether you do it the yellow way or the orange way, it's really up to you. They're both not bad ways. They're both simple, straightforward, and it's a nice question for 2 marks. Okay, so it's about the sort of either you'd have to have thought it like this and then moved there, that would have been your 2 marks, or you would do the substitution and then get the answer and give it as, so the answer would be 1, and this would be your 2nd mark when you give the maximum value. Remember, it's no good writing it in that form and not answering the question. The question said write down the maximum value. If you're someone who forgets the question, make a habit of underlining the actual part you have to provide. Okay, let's see what else there is here. Right, it says here, a parabola f intersects the x-axis at B and C. We've got this already. We know that this is -1, this is 7. We know the equation of this is y equals a half x minus 3 all squared. Was it -8? Yeah, -8. Right, let's see what this question asks. It says solve for this. Now, once again, we have a choice of 2 possible approaches. The one approach is the good old traditional one, that you're just going to go to your equation f and substitute it in. So wherever there's an x, you're going to put x squared minus 2, and then you're going to work with it. Of course, it's going to make work for you. We know that already. Now, obviously, if you do that, there's a little problem. Let's show you what the little problem is. Remember, our f of x was a half x minus 3 all squared minus 8. So if we go over here and we say, what is the f of x squared minus 2? Well, we know wherever there's an x, I'm going to put that. So this x here is going to be replaced with that value. So it's a half. Open the brackets. In place of the pink x, you're going to write x squared minus 2. And then the rest of the yellow equation will apply. Minus 3 squared minus 8. Right, so if we look at that, we now have a half x squared minus 5 all squared minus 8. Now, a squared makes your equation become a power 4 equation. Now, this one isn't too bad. I think we can manage to solve it out without too much trouble. I will show you eventually a little bit better method. So what I'm going to do here is I'm going to take the 8 over. So 8 equals a half x squared minus 5 all squared. I don't want the half, so I'm going to multiply this side by 2 and that side by 2. So I'm going to get 16 equals x squared minus 5 all squared. Now, if we've got, let's make it a squared equals 16. You'd have no problem with it. You'd just say, well, if it's a squared equals 16, then a is equal to plus or minus 4. So you would say a is plus or minus 4. So it's no different here. You're going to say x squared minus 5 is equal to plus or minus 4. You're going to split it up now. You're going to say x squared minus 5 equals negative 4. Or, very important word, I'll explain to you why in a moment, x squared minus 5 equals 4. Now, why did I say that's an important word? Because any of these solutions will make that become 0. So we could have this or this. And we can't say the word and, because the and word means that they both must apply at the same time. I always think of it like asking your friend to arrange a blind date for you. And you say, please find me a guy or a girl to go out with who is good looking and intelligent. And you really wait for this date. Then you get desperate, you've waited like 3 weeks, you say to your friend, you know what, make it good looking or intelligent. And now you get a date the next week, because it's not so hard to find one of the qualities, but to find both is much more difficult. So here it can be either or. So let's see what happens here. We're going to get x squared equals minus 4 plus 5. So x squared is equal to 1, which means x is plus or minus 1. Over here, we're going to get x squared equals 4. I better do all the steps, plus 5, which means x squared is equal to 9, which means x is plus or minus 3. In other words, the answers are x equals minus 3, or x equals minus 1, or x equals 1, or x equals 3. So we have 4 answers. Does that make sense? Why would we get 4 answers? Well, what do we know if we're solving an equation? We look to the power or the exponent of the expression or the equation, and if it's a power of 4, that means we can have up to 4 different answers. We will have 4, but sometimes they're the same. In this case, there were 4 unique solutions. So if we have a look here, we've got -3, -1, 1, and 3. All 4 are different. Okay, right, so now we've cleared that up. Let's talk about a nicer way to have done this. Right, now what do we know? We know over here that x would have equaled -1, and over here we know that x would have equaled 7. So let's change to pink so you can see the difference in the solutions. But this time, instead of x, we are using x squared minus 2. So what we could do is we could say x squared minus 2 equals -1, or x squared minus 2 equals 7. And look how much quicker we got to that answer. There was nothing wrong with the other way. It just took a little bit longer. So what I'm trying to say to you here is sometimes things will take longer. But if you're guaranteeing yourself that you'll get it right, it's worth that time. If you've got a short way that works for you and can get you out really quickly, well then use it to your advantage. So basically what I'm saying here is the x-intercept is -1. The other x-intercept is 7. So if you like, this little x here was that, but we want x squared minus 2. So now we would say x squared equals 1. X is plus or minus 1. Over here, x squared equals 9, and therefore x is plus or minus 3. So in actual fact, using this method cuts us down to this part only. Right, that brings us to the end of that question. And as you can see, quite a lovely question with lots of parts to it. Now, we're going to add break, have a bit of a stretch, and be ready. We're going to come back and we're going to handle another question that does something slightly different. Welcome back. Let's look at the next question. That's question number 2, and it's adapted from the February-March 2010 paper 1. It was question 6. Basically what this question does is it gives you the 2 equations. It says the graph of f of x is minus x squared plus 7x plus 8, and g of x, which is minus 3x plus 24, are sketched below. So let's go and have a quick look at that. We're looking at the parabola, which has equation y equals minus x squared plus 7x plus 8. That fits around what we know. We know that if it's a negative in the a value, the graph would be sad. And the straight line is y equals minus 3x plus 24. I always like to write the equation of the graph on the actual graph because it just makes it so much easier to think of the questions. Now the first question says, determine the coordinates of A and B. And now this is not hugely different from the first question because A and B are my x-intercepts. But what is different is we are now finding the x-intercepts of the parabola, and that's no problem because we've got the equation of the parabola. So let's jot it down. It's y equals minus x squared plus 7x plus 8. And we want the x-intercepts. So we are going to let y equals 0. So 0 is equal to minus x squared plus 7x plus 8. Now, if we look at this, some people try to factorize with a negative there, but that's never a good idea. Rather have a positive x squared term. Just easier to get your signs right and everything. So we would say 0 equals, because what I'm doing in effect is multiplying every single term by negative 1. It's going to be x squared minus 7x minus 8, which means our factorization becomes relatively easy. We know it will be an x and an x, an 8 and a 1, a minus on the 8 and a plus on the 1. So we know that the x will equal 8 or the x will equal minus 1. Now, what did they ask me for? They asked me for the coordinates of A and B. So it's no good leaving the question at this stage because that's not going to help us at all. So what we have to do now is we have to decide from the drawing which one's A and which one's B. The A one is the negative one and the B one's the positive one. So this coordinate would be 8, 0, and this one would be minus 1, 0. See, if you don't return your answer in the form they ask you for, it costs you a mark, which is a real shame when you knew exactly what you were doing. So instead of 4 marks, you get 3 if you stopped your question off at this stage. Right, so going back to the drawing, I'm a great believer in always putting the information on the drawing. So it's -1, 0, and this is 8, 0. Why it's a good idea to put it on the drawing is it helps you to check your answers are relevant or possible in the first place. Right, let's see what 2.2 asks us. Right, so we said this was -1, 0, and this was 8, 0, and they now ask me to calculate A, the x value of D. So the x value of D, there's the x value. Right, so how do we get a point up there on the thing? Well, it's where the parabola and the straight line cross. In other words, it's a point of intersection, and we get that by solving the equations simultaneously. So let's go to the two equations, which I have forgotten. It is y equals minus x squared plus 7x plus 8, and the other one was y equals minus 3x plus 24, I think, but let's just make sure. Right, so those are your two equations. Now, if we're going to solve equations simultaneously, and one is linear and one is parabolic, the best approach is a substitution approach. So we would number these equations number 1 and number 2. Always try and help your examiner so it's easy for them to follow what you're doing. And now you tell them, I'm going to substitute equation 1 into equation 2. In other words, where there is a y here, I'm going to replace with minus 3x plus 24. So we're going to go minus 3x plus 24 equals, and then the rest of the equation is what was there, minus x squared plus 7x plus 8. Now, as you can see at this moment in time, the whole equation is in x. So what we're going to do is we're going to solve for x. And remember what I said to you about avoiding the negative in front of the x squared. So I'm going to transpose it this side, so it will become x squared. This one over here is minus 7x. And this one over here is minus 8. And then I've still got my pink equation, which is minus 3x plus 24. But now it's equal to 0. So if we tidy up, we have x squared. Minus 7x minus 3x is actually minus 10x. And minus 8 plus 24 is actually plus 16 equals 0. Now we're going to factorize this. And again, it's quite nice factorization because we've avoided any complications here. It's x and x. And we want factors of 16 that when added together give me 10. And there they are. And so I'm going to get the answer x equals 8 or x equals 2. Why are we getting two answers? Well, this thing was a quadratic equation, which means we can have up to 2 different answers. We can get one that's the same, or we can get 2 different. So if we go back to the drawing, let's see what we got. We got 2 and 8. But this one here is 8, so that makes perfect sense. So this one, the D, must be 2 something. Now, have we done the question? They said calculate A. That was just the x value of the coordinate D. So yes, we have done what they want. And so all I would do is I would say, to finish the question, A equals 2, because they asked me to calculate A. Notice I underline the answer. It's always a good idea. It just helps the examiner or the marker to know that this is where you've come to the end of your question. All right, so let's see what the next bit brings. Right, the next bit, and I just want to try and put in some of this value stuff we've worked out, just so we can refer back to it. I think there was 8, 0, minus 1, 0. We might not need it, but just in case. Right, it says S of x, the coordinate xy, is a point on the graph of f, where x lies from a to 8. Well, a we know is 2. So they're telling me x lies between 2 and 8. SG is drawn parallel to the y-axis with T on the graph of G. Find ST in terms of x. It's 2 marks. We're not going to work too hard for 2 marks, but let's go and have a look at what it says. Right, so there's your ST. This is parallel, so in other words, if I continued down, this would be at right angles to that x-axis. Now, just in simple terms, just to make you understand what I'm doing here, supposing I drew this and I gave you a value here, say I said this was 4, 6, and over here, I would say this is some other point. Do you agree with me that the x values would be the same? So since they are perpendicular to the x-axis, their x values will be the same, but this one would be something smaller. So if I wanted to know this distance, what would I do? I would surely take the y value of the top point, subtract the y value of the bottom point. So in this case, if this was my ST, I'd take the y of S minus the y of t. So it would be 6 minus 2, which would give me 4 units. Now, obviously, we don't have the actual points, but we have an abstraction of it. So what's different is nothing really. We're just going to work in x's instead of in numbers. So what I'm going to do is I'm going to go to this, and I know that any point on this parabola, and this is well worth knowing. So let me just get rid of this because I think we can do without that little bit there, just to give us a little bit more space. This coordinate here, S, will have the form of x, and whatever that x was, to find the y, I would substitute into the equation which I've got, which is minus x squared plus 7x plus 8. Likewise, over here, the t would also be x, but to find the y that goes with it, I would substitute into the g of x equation. So it's minus 3x plus 24. So what some teachers teach, and it's not a bad way to go, they say if I want ST, I take top graph minus bottom graph. What they're meaning is I take the y value of S, subtract the y value of t. So the y value of S would be the equation of F, and the y value of t would be the equation of G, sorry. Right, so it would be minus x squared plus 8x plus 7. I hope I've written it down correctly. I must always just... No, it's the other way around, just as well I checked. So later on we would have run into some trouble. So it's 7x plus 8. And that would be your y of S. Subtract your y of t, which would have been the minus 3x plus the 24. And that would give me the distance ST. Right, so now it just becomes an exercise in tidying up because they asked me to give the answer in terms of x. And those are x's, so all I've got to do is make it look better and we have got it organized. So it's minus x squared plus 7x plus 8. Effectively, that's like having a minus 1 in front, so we're going to multiply it in. So it's going to be plus 3x minus 24. Which is equal to minus x squared plus 10x minus 16. Okay, so that's not bad. Have we answered the question? Yes, we've expressed ST in terms of x, which is what the question asked. 2 marks. I personally think the marks would come from the realization of that and the final conclusion where you write it down nice and neatly. Okay, so that is 2.3. So let's see what 2.4 asks me. Whoops, I think I went a little bit too far. Here's 2.4. 2.4 says calculate the maximum length of ST. So back we go. Let's pick up the equation for ST. It's minus x squared plus 10x minus 16. Let's check again. I don't want to give you the wrong equation because then we're going to be in trouble. Minus x squared plus 10x minus 16. Yeah, that's right. Right, so what we have to do now is find the maximum length of that. Now, we have 2 ways. In grade 11, you would have been taught to do this by completing the square. In grade 12, we have very good news for you. We use calculus. And calculus is always an easier way to do it. but I think I do have time to do both. I'll do the calculus way first because that is the easiest way, and then I will show you the grade 11 approach. But I just want to caution you with the grade 11 approach in that if it had been a cubic equation ST or some other equation, not even cubic or anything, say kind of hyperbolic kind of thing or something, then you could not use completing the square. You can use completing the square here because you are working with a quadratic equation. So let's do the calculus method because that's the one that will not let you down no matter what. So we know that ST is minus x squared plus 10x minus 16. Okay. Right, now what does calculus say to me? Well, it says to me if I want to find a maximum or a minimum, so for a max or a min, we would take the derivative and put it equal to 0. Why is that? Well, if you think about your graph, let's draw it for you. If I think of a cubic graph, the gradient is positive here, it's negative there. It would go through 0 at this stationary point, which would be your local maximum in this case. Here it's gone from negative through to positive, so that would be where the gradient is 0. And gradient is the derivative of the function. So it's making perfect sense. Of course, here we're dealing with a parabola or quadratic equation, so we know there'll only be one, and it'll be a genuine maximum or minimum. It won't be both. So right, let's go back to that and let's carry on going. So if I take the derivative of ST, I like this notation. It really doesn't matter. You could use dst dx, or you could, I think that would be your safest, to use this one or this one. I personally like this one. So if we take in the derivative, we take the 2 in front, so we get minus 2x plus 10. So remember, constant, the derivative is 0. Now, for the min or max, we're going to put that equal to 0, and we have to solve for x. So 2x is equal to 10, and x is equal to 5. So what I know is this minimum or maximum happens when the derivative equals 0, and that is when x is 5. In other words, if I go back to this drawing and I carry this point down, I know that that x value is going to be 5. So I know that that will be 5 something, and we're going to talk about that, and this over here would be 5 something. Now, the beautiful thing of the calculus approach, we just simply take this x value and substitute in. But what we should do first of all is establish whether it's a max or a min. So the first way is to say, look, this is a parabola. It's a negative one, so it will have this shape. In other words, its turning point will be a maximum. The other way is to use our calculus, which says our second derivative decides if it's a max, min, or point of inflection. So if I take the second derivative of this, it would be minus 2. If it's less than 0, it's a maximum. So that's 2 different ways. In this case, I probably would have used that. It's easier than this, but it's not a huge difference really. So right, now we know that this happens when x is 5. So what I'm going to do now is I'm going to go to my expression, st, which was minus x squared plus 10x minus 16, and I'm going to go and substitute in every x equal to 5. So it's 5 squared plus 10 times 5 minus 16. And so that's going to give me minus 25 plus 50 minus 16, which means that's going to give me 25. 25 minus 16 is going to give me 9. I think I'm right. Let me check. Yes, that's right. Sorry, my 9 looks a little bit curly there, so let's just make it look a little bit better. That's 9. Right, so I'm saying to you the maximum length of ST is 9 units. And I would say maximum length of ST is 9 units. See, I have no idea whether this is centimeters, meters, whatever. Doesn't matter. I just call it units. Then it covers me. Right, now let's do the grade 11 method. And as I say, caution, if it was anything else but a quadratic, you could not use your grade 11 method. But I think it's worth me showing you just so that you've seen that there is an option if you're not confident. But hopefully your calculus is good. Remember, your calculus is a good 33% of your paper 1. So you want to rather get really good marks for that. So let's go to the other option, where we take the ST as minus x squared plus 10x minus 16. Now what we're going to do is we're going to complete the square on this. So we're going to say ST equals, take out the minus. Remember, I only take it out of the first two. So it's going to be x squared minus 10x, leave a space, minus 16. If I multiply out at any stage on my completing the square, I've got to get back to where I started, otherwise I've made a mistake. Now the next thing I do is I take the value of minus 10, I times it by a half, which is minus 5, I square it, which is 25, I add it, and I subtract it. However, remember what I said to you about the half earlier, that will make it a plus. Because if you times here, that's going to be a negative 25, which means you must have a positive 25 to counteract it. If I multiplied out at this stage, I would get back to where I started. So it's equal to, and now I can finish this up, it's minus, this is going to become x minus 5 all squared, and this over here is going to be positive 9. What do we know? We know that the maximum value of ST is equal to this value at the back, the Q value of the turning point. Remember, it would be 5, 9. So that means ST is 9 units. And that would be the end of the question. But as I say, just be warned. It's very nice and easy and simple to do this. But just be warned in case it's not a quadratic. Then you have no choice but to work with the calculus. Just quickly, before we go to the end of the program, I'd like to just show you something which I think is quite interesting, and I'm sure your teachers probably have mentioned it. But just in case, I'm going to mention it now. Do you agree with me that that is the standard or the general form of a parabola or a quadratic function? If we take its derivative, we are going to get 2ax plus b. Once we're there, remember what I said to you. I said for a max or a min, put the derivative equal to 0. So 0 is equal to 2ax plus b. So that means that 2ax equals minus b. Now, I don't know about you, but I like my x's on this side. It's just a habit. And I divide this side by 2a and this side by 2a. And so x is equal to minus b over 2a. And if you haven't seen it before, I'm sure you're screaming with joy because you know that that's the formula we use to find the axis of symmetry. Remember, the axis of symmetry is the x value of the turning point. So it all makes perfect sense that this would be, if you like, the p-value of your turning point. To get this, you take that value and substitute it in to find the y-value that goes with it. Okay, now I think at this stage we need to wrap this all up. So all I want to say to you at this stage is just be aware that different questions go a long way. This maximum question is a very popular one. Things like reflections about axes, like we did in the first question, also extremely important. And they get to ask you all sorts of stuff within these questions. They can get you to do simultaneous, they can get you to find and solve equations, they can get you to do symmetries and reflections. And so really, it's a wonderful way for an examiner to test several sections of mathematics in one. Anyhow, good luck with the studying, and I hope you are going to have a very successful examination. See you soon.